Alright, testing 1 2, testing 1 2. Let's read these questions. This is airframe block 6. Second half of the questions, I only got through like a little bit portion because my roommate was being really loud, so I didn't want to keep on reading because she was in there making all this kind of noise. So let's pick back up where we left off. We're on number 69. Alright, so here we go. Alright, so what is the main purpose of a servo in an autopilot system? To move the control surface on command. So what is the main purpose of a servo? To move the control surfaces onto command. So just remember, like on an RC, like RC plane, you know, the videos, they're always like talking about servos and stuff. So just remember, it moves the control surfaces on command. Servos move control surfaces on command. So which channel of an autopilot detects changes in pitch attitude of an aircraft? The elevator. Which channel of an autopilot detects changes in pitch attitude of an aircraft? The elevator. The elevator. So autopilot detects changes in pitch attitude through the elevator. So the elevator channel of an autopilot controls the aircraft about which axis of rotation? Lateral. So the elevator channel of an autopilot controls the aircraft about which axis of rotation? Lateral. Alright. So what component is the sensing device in an electromechanical autopilot system? Gyro. So what component is the sensing device in an electromechanical autopilot system? The gyro. So the gyro is the sensing device in an electromechanical autopilot system. Too easy. A fully integrated autopilot controls the aircraft about how many axes? 3. 3 axes. Longitudinal, lateral, and yaw. So it's on 3 axes. So a fully integrated autopilot. That's what you gotta. That's your keywords right there. Fully integrated autopilot controls the aircraft on how many axes? 3. A fully integrated autopilot system controls on 3 axes. So just remember that. Don't put 4. Don't put 2. Put 3. So Dutch roll, a combination of yawing and rolling oscillation that affects many swept-wing aircraft, is counteracted with a yaw damper system. So a Dutch roll, a combination of yawing and rolling oscillation that affects many swept-wing aircraft, is counteracted with a yaw damper. So we just need to shorten that one because that's a lot of BS we're talking about right there, boy. I'll tell you, boy, right there. So a Dutch roll is counteracted with a yaw damper system. Dutch roll, yaw damper system. Dutch roll, yaw damper system. Cool. Oh, what just happened? Alright, should I scroll up or something? So when operationally checking an autopilot system on the ground, after the aircraft's main power has been switched on, the autopilot should be engaged only after the gyros come up to speed and the amplifier warms up. So when operationally checking the autopilot system on the ground, after the main power has been switched on, the autopilot should be engaged only after the gyros come up to speed and the amplifier warms up. It's pretty easy, pretty common sense there. So, installed radio equipment is protected from damage due to joints and vibration by shock mounts. Just like we talked about in class. So shock mounts. I know like those other ones are confusing. I almost put the other ones, but it's literally a shock mounts, bro. Like, installed radio equipment is protected by shock mounts. You know, don't even think about those other words like jolts, vibration. I mean, obvious, but yeah, it's just shock mounts. Not spend too much time on that. So this one, one of those questions. So, you know, 1 and 2, which one is true? So use solder to attach body jumpers to radio equipment. So I don't think that doesn't sound too correct. So radio equipment is bonded to the aircraft in order to provide a low impedance ground and to minimize radio interference from static electrical charges. Yeah, that sounds right. So yeah, only 2 is true on that one. Radio equipment is bonded to the aircraft to provide a low impedance ground and to minimize radio interference from static electrical charges. So yeah, that's what ground is. So only 2 is true. Yeah, we don't solder jumpers to them. So when must the radio station license be displayed on an aircraft equipped with a two-way radio? When the aircraft is operated outside the US. So when must the radio license be displayed? If it's a two-way radio, when the plane's outside the US, because US is the best, so everybody knows it. So if the plane's outside US and you got two-way radio, you better display your license or else they're gonna come get you. So yeah, pretty easy there. So two-way radio, display license, only outside US. Too easy. So this one, it kind of confuses you. So when would a US resident not be required to hold a Federal Communications Commission, so FCC, restricted radio telephone operator permit? Jesus Christ. To operate two-way radio, VHF radio equipment. So when flying within the US, so see, they're trying to trip you up, bro. So when you're flying within the US, you do not need a FCC permit for two-way radio inside the US. See, so you gotta pay close attention. When would a US resident not be required to hold an FCC restricted radio telephone operator permit to operate two-way radio, very high frequency radio equipment in the aircraft? Answer: when flying or communicating within the US. So the first one, so the last one was outside the US, for two-way radio, two-way license display outside the US. Don't get that confused with this one. When communicating inside the US, you don't need FCC. It's not required. US resident, not required for the FCC radio equipment in the US, inside the US. If y'all get that wrong, I'm gonna be so mad. If you get that wrong, put it in the comments. I told you to get that one correct. So you better not find out. So moving forward, part of the ADF system used on aircraft includes sense and loop antennas. Too easy, like that's just self-explanatory. I don't know who wouldn't understand that. So part of the ADF system used on an aircraft includes sense and loop antennas. So just pretty simple, bro, like just self-explanatory. Sense and loop antenna, ADF system, sense and loop antenna, ADF system, sense and loop antenna. Like too easy, this stuff's too easy for y'all, bro. I'm just trying to, they're just giving these licenses away, bro. Sheesh. So when installing coaxial cable, it should be secured firmly along the entire length at 2 foot intervals. I got this one wrong. I put 1 foot. You better not put 1 foot. If you put 1 foot, bro, I'm gonna be so mad. Like, if you put 1 foot, I swear to God. Just remember that 2 foot intervals for coaxial cable. 2 foot interval, coaxial cable. So, I hope y'all don't get that one wrong like I did. Because I put 1 foot. Because I thought it'd be 1 foot. So when must the emergency locator transmitter, the ELT battery, be replaced other than reading the replacement date? When the transmitter has been in use for more than 1 cumulative hour. So yeah, I mean, I don't know how else to explain that other than what it says. So when must the ELT battery be replaced? When the transmitter has been in use for more than 1 cumulative hour. Cumulative hour. What a stupid word. So when must ELT battery be replaced? When it's been for 1 stupid hour. That's what we'll call that. Stupid. So an emergency locator transmitter battery, Jesus Christ, ELT battery must be capable of furnishing power for signal transmission for at least 48 hours. That's the very minimum. So I almost got that one wrong, but I just put 48 because I felt like that was, I watched the first 48 growing up, so I just went with my gut on that one. So an emergency ELT, so an ELT battery must be capable of furnishing power for the first 48. So just remember that, bro, just like that TV show. The battery must be capable of furnishing power for that first 48, dog. Come on, dog. So, battery must be capable of furnishing power for at least 48 hours as a minimum, bro. As a minimum, 48 hours. So, ELT battery must be capable of furnishing for 48, dog. That first 48, you already know. So, let's keep it moving here. The preferred location of an ELT as far as possible but forward of the vertical fin. Man, these people love that ELT right here. Next 5 questions about the ELT. Jeez Louise, Papa Cheese. Let's go. Let's talk about this ELT. So where's the preferred location of an ELT? As far possible but forward of the vertical fin. Why is that? Because that's your emergency locator transponder, bro. That's your emergency locator transponder, bro. You want that as far possible but before the fin, bro. Because when a plane crash, it falls in a couple pieces, right? The tail can fall off, but the forward fuselage, kind of intact and stuff. So you want that cable right there. You want that antenna sticking out right there, boy. You want it sticking out right there, boy. Forward of the fin, boy. As far as possible aft, boy. Where's that ELT location? Far as possible aft, but forward in front of that vertical fin, boy. Let's go. Let's do this. Let's keep talking about this ELT. An emergency locator transmitter. Oh, I was calling it transponder. Jeez Louise. So, emergency locator transmitter is normally activated by an internal switch or equivalent mechanism if subjected to a force of a prescribed intensity and duration. It must activate when the force is applied parallel to the longitudinal axis of the aircraft. I put vertical, bro. He said vertical, bro. Oh my gosh. So I guess it's parallel to longitudinal. I don't know why I got that. I don't know why he showed us that picture wrong. So yeah, I guess it's parallel to the longitudinal axis. So an ELT is normally activated by an internal switch or equivalent mechanism if subjected to a force of a prescribed intensity and duration. So it's basically a crash. So if a mechanism is subject to a crash, it must activate when the force is applied longitudinal of the axis of the aircraft. And I guess, see, all those sensors sit longitudinally, so like horizontally, not vertically, not up and down, they sit longitudinally. So once that plane crashes, planes fly through the sky like that, they don't fly up like a rocket. So I guess that would make sense to put it vertical if it's on a rocket. But so they put it horizontally, longitudinally on a plane since they fly like that through the sky. So if it crashes, all those sensors will kick off. So yeah, ELT It will activate by that switch or by a crash. And if the force is applied parallel to the longitudinal surface. So cool, we spent a lot of time on that. So yeah, longitudinal axis is activated when force is applied on longitudinal axis. Moving along. How may the battery replacement date be verified of an ELT? By observing the battery replacement date mark on the outside of the transmitter. Holy cow. They're just giving us these answers, bro. Like, if you just read those questions, I mean, you just read those answers they have there, it's pretty stupid. If you just say by observing the battery replacement date, it's freaking too easy. How may the battery replacement date be verified? By observing the replacement battery date marked outside. Like, how simple can this get for you, bro? How are they not giving you this license yet, bro? If you fail this test, like, and you haven't taken block 4 yet, like, there's like 3 people in my class that haven't taken block 4, and they take this class first. Like, the teacher, like, the school kind of screwed them over. But I can see them failing because they don't know the basics. But yeah, this stuff, bro, like, if you took block 4, you should be able to pass this test. Because that's pretty easy, bro. So moving forward, how may the operation of an installed emergency locator transmitter, I'm telling you, 20 questions of this thing, be verified during inspection? How may operation of installed ELT be verified during aircraft inspection? By tuning a communications receiver to the civil emergency frequency and activating the ELT momentarily within 5 minutes after the hour. So within that first 5 minutes, so 105 and under, like 205 and under, like, you know, 305, you don't want to go 306, it's too late. It'll cause emergency. You gotta wait till the next hour, bro. So do it like within that first 5 minutes. So when do they want that test to be done? By tuning the receiver to the radio frequency within the first 5 minutes after the hour. It should just say first 5 minutes of the hour, but they're trying to trip you up with the stupid words. So within 5 minutes after the hour. Within 5 minutes after the hour. Just look for that keywords, because one of those can trip you up. If you put the wrong one, it's because you didn't read it right. So that's on you, Bubba. So within the first 5 minutes after the hour, you want to verify that check of the ELT. Hopefully, if they talk about ELT one more time, bro, I swear to Bob, I'm gonna turn off this computer and just make a part 3. So, static discharge helps eliminate radio interference by dissipating static electricity into the atmosphere at low current levels. I got that one right just because I guessed it. I was like, it's always low. Like, so that's correct, it's always low. So static discharges help eliminate radio interference by dissipating static electricity into the atmosphere at low levels. It's not high voltage. Static doesn't have high voltage. It's not high current. Static doesn't have high current. It's low current. Static is low current. That's why, like, when you shock, like on the slides, remember when you were a kid at Chuck E. Cheese and stuff? You know, McDonald's, when they still do that. I don't know if after COVID, I don't know if they still do that. But it shocks you because static is low levels, bro. Static is always low. Just remember. So it's a lot of time on that question. An aircraft antenna installation must be grounded to the airframe. You should know that by now. If you took block 4, you should know that. If you should know that. I mean, I'm not saying you should know that like by now, but yeah. It's grounded to the airframe. So we're an airframe block. So that's how you should remember that. Airframe is installed to the airframe. Antenna is grounded to the airframe. Moving right along. VHF radio signals are commonly used in both VOR navigation and ATC communications. I forget what those really stand for, but very high frequency radio signals. That's what that is, VHF, very high frequency. So VHF radio frequencies are commonly used in both VOR navigation and ATC. So I mean, both the answers are there, just pick C. I mean, yeah, it's probably gonna be C for that answer anyways. So yeah, both of them. So on modern large aircraft, what electric device typically monitors flight parameters and performs autopilot functions. The flight management computer, like basically like a car, like your CPU, like your computer module unit, whatever. This is basically what that is, like flight management controller, like FMC. I mean, I don't know if that's the real thing, but it's like the same thing, like CPU. I mean, your ED, CPM, what is that called? CPU, something like that. So major adjustments on equipment, such as regulators, contactors, and inverters, are best accomplished outside the airplane on test benches with necessary instruments and equipment. Adjustment procedure should be outlined by the equipment manufacturer. So who should make major adjustments? The equipment manufacturer. Who should make major adjustments on equipment, such as regulators, contractors, and inverters? The equipment manufacturer. Cool. A battery generator system provides direct current. On installations requiring alternating current from the battery generator system, it is necessary to have an inverter. So a battery generator system provides DC on installations requiring AC current from the battery generator system. It is necessary to have an inverter. So an inverter changes DC to AC. So how do you change AC to DC? I mean, how do you change DC to AC? With an inverter. So invert DC to AC. So then what changes AC to DC? The rectifier, I'm pretty sure. Yeah, rectify AC DC and invert DC AC. So invert DC to AC and rectify AC DC. So yeah, you don't want to confuse those. So you want to invert DC to AC, invert DC to AC, invert DC to AC. Remember that one. An aircraft electrical circuit control relay is an electrically operated switch. Oh, electronically operated switch. An aircraft electrical circuit control relay is an electronically operated switch. Okay, so an aircraft electrical circuit control relay is electronically powered, or electronically operated. Electronically operated. Pretty much in the name. Control relay, because a relay is a switch. So the purpose of a rectifier in an electrical system is to change AC to DC, just like I said. So the purpose of a rectifier is to change AC to DC, just like that band. So like, I hope it, remember, it's like doesn't make any sense, but just rectify AC DC. Like that doesn't mean anything, but it helps me remember it. Rectify, that sounds like a song. Rectify, I don't know. Rectify AC/DC, sounds like something they would do. I don't know. So yeah, rectify AC/DC. And the purpose of rectifier is AC to DC. What is the ratio of turns between the primary coil winding and the secondary coil winding of a transformer designed to triple its input voltage? Primary will have 1/3 as many turns as the secondary. So what is the ratio of turns between the primary coil and the secondary coil of a transformer designed to triple its input voltage? So primary will have 1/3 as many. So 1/3 as many. Triple its input voltage. I'm trying to like understand this, like picture it. So what is the ratio of turns between the primary coil winding and the secondary coil winding of a transformer designed to triple its input voltage? Primary will have 1/3 as many turns as the secondary. So in an AC circuit with no phase lead or lag, what is true? Real power equals apparent power. So real power equals apparent power. In an AC circuit with no phase lead or lag, real power equals apparent power. RP equals AP. Real power equals apparent power. Real power equals apparent power. An AC circuit with no phase lead or lag. With no phase lead or lag, real power equals apparent power. Try to remember that one. How are generators rated? Amperes at rated voltage. Amperes at rated voltage. Hope I don't get that wrong. Amperes at rated voltage. How is a shunt wound DC generator connected? Both fields are shunted across the armature. I remember that question. I remember reading that on the slide. How is a shunt wound DC generator connected? Both fields are shunted across the armature. How is a shunt wound DC generator connected? Both fields are shunted across the armature. So these need pictures, bro. I don't know what shunt wound really is. I know the armature is the whole alternator itself, basically a generator thing. Since you place that in the growler, that's what that one question was. How do you test the armature? Put it in the growler. They put that whole thing in the growler. I thought that was just a whole. I don't even know what that was. But yeah, that's just hard. How is a shunt wound DC generator connected? Both fields are shunted across the armature. This type of stuff you just have to remember. Both fields are shunted across the armature. Both fields are shunted across the armature. So, that's how they're connected, I guess. So the poles of a generator are laminated to reduce eddy current losses. So poles of a generator are laminated to reduce eddy current losses. So the poles of a generator are laminated to reduce eddy current losses. I'm trying to picture that, but I just can't. The poles of a generator, so the poles, okay? I'm thinking about the poles. Are laminated, so they laminated it with something to reduce eddy current loss. So the lamination must stop this power from going out, I guess. So it reduces. So whoever thought of that is the reason why they do it now. So reduce eddy current loss. The poles of a generator are laminated. The poles are laminated to stop the current loss. Cool. So yeah, that's the end of that block 6 review. So yeah, just check out part 1, and then this is follows right up off of that. But yeah, so check out both of them. I'm gonna do more of the other blocks here soon, while I study for the generals, since I just finished with that. But yeah, so appreciate y'all tuning in. Hopefully this helps.